of you, dear chairman, dear fellow professors, and dear colleagues and participants. First of all, I would like to thank to the organizers for inviting us of such an important event. Then I would like to congratulate to your committee and the country for enforcing such an important document, and to thank on the third place to the valuable professors for their presentation, which is of course, I mean, we can find the similar ideas, the similar concepts, maybe somehow difference in some points, but anyhow, very useful for us. So thank you once again for this. So I will speak today for the historic monuments and building in our country. And I will start with some introductory slides about our institute and about the earthquake engineering as a discipline. Then I will speak about this issue about in the Balkan region, in general for cultural heritage and cultural heritage in our country. And then I will present the integrated approach which our institute developed and implemented in variable monuments. So our Institute for Earthquake Engineering and Engineering Seismology was established in 1965 upon the recommendation of the UNESCO within the St. Cyril and Methodius University Skopje. And while meeting the immediate needs for the recovery of the Skopje after the catastrophic earthquake in 1963, it creates conditions for permanent progress in education and training, in research and science, and of course in applying of this knowledge into the everyday practice. Its own basic activity, our institute is organized through 6 departments, 5 laboratories, and one, as you can see, Center for International Cooperation that we present today here. Represented is the ETSILS, European Center. It has about 73 employees, 24 of which are representing the teaching staff. We present here today from North Macedonia. We are also members of the Building Structure and Material Department, which primarily focuses into the, let's say, design of new, of course, seismic resistant structure, but also in diagnosis, repair, strengthening of existing structures, and of course, some connected with this professional opinions, expertise, consultancy, etc. So because our institute is inevitably connected with earthquake engineering, the next 2 slides will be recalling of some historic background. So the protection from earthquakes, of course, begins with the early nowadays missing civilizations. Although in that times, of course, earthquakes has been considered as the God's will of the products of mystic forces. I'm interested into the earthquakes and its consequences increased in the 19th and beginning of 20th century, mainly after the major earthquakes in United States, Italy, and Japan, and results in the establishment of very important institutions in those countries and birth of the, let's say, practical seismic design analysis of the earthquake resistant structures by means of equivalent static method, which later on was adopted in the several codes. But we can say that the modern approach to earthquake engineering starts with the first International World Conference of Earthquake Engineering and commemorating of the 50 years of San Francisco earthquake in 1956, when there was only 40 participants from 11 countries with only 3 topics. And the second one in Japan, when the International Association of Earthquake Engineering was established. So it is the most important event, because since then, these conferences are organized every 4 years, with continuously increasing the number of participants, the topics, etc., and its origins. But the repair, strengthening, and retrofitting appears in the 1977 during the 6th World Conference, coming to the motto towards resilient society in the last one in Japan, which we can say reached the ultimate goal of earthquake engineering, which is control the seismic risk at the socio-economically acceptable levels. Of course, at the next one in Milan, it is expected that more than 3,000 participants will be, and the novelty is that the topics are proposed by the participants. Similarly, we can speak about the development of the European earthquake engineering. The key event for the European earthquake engineering was the 1963 catastrophic Skopje earthquake, which brings, of course, 1,071 deaths, more than 3,000 injured, and the losses are calculated to be equal to the 15% of the GDP of the ex-Yugoslavia in 1963. This was really unique earthquake among all of these earthquakes in Europe and Mediterranean, because he triggered a high level of awareness of all the participants, all the, let's say, the government, the engineers, the politicians, etc. The high level of awareness and activity by the government into the need of implementation of the organized and sustainable effort in the disaster risk management. And the very important role, as Professor Tassius mentioned, it was the role of the UNESCO by their activities and their financial support into the proceeds activity. And for us, of course, this was the most important one is the enforcing the first seismic code in the ex-Yugoslavia and first standardization in 1964. And of course, the establishment of the European Association of Earthquake Engineering during the first international seminar. Now we are calling that this is the first European Conference on Earthquake Engineering, which is, of course, a symbol of the beginning of the European earthquake engineering. And of course, this conference is also, of course, well organized every 4 years. The final one or the next one will be in Berlin in 2026. So during all of these conferences, the great lessons have been and will be learned about the earthquake performance, the earthquake nature, about the performance of the structures, of the geotechnics, etc. And more, I mean, the majority of them have been accepted and incorporated into the codes. However, the applying of regulation of the existing buildings is an area less well defined. So what happens in Balkans in this way? So significant for this issue for the Balkan region is the manifestation of the seismicity. Skopje earthquake 1963, Debar earthquake 1967, Banja Luka earthquake 1969, all in the territory of ex-Yugoslavia, Vrancea earthquake 1977, Thessaloniki earthquake 1978, and Montenegro earthquake 1979. So in only 15 years, several deadly earthquakes, which caused demolition of most of the building stock, many injured, and more than 3,000 deaths. So the extremely important role in overcoming these problems, again, I will speak, this is the UNESCO agencies. First of all, because of the formation or establishment and financial support of our institute from 1965 to 1982, and especially through development or to starting and realize the implementation of several projects due to the seismicity of the Balkan region, the earthquake risk reduction, and the construction of earthquake resistant structures. The final one which was mentioned by Professor Tassius, it is the building construction under seismic conditions in Balkan region, UNDP UNIDO conference, 1979-1984. The most important why? Because in carrying out of this project, the participation of the governments of Bulgaria, Greece, Hungary, Romania, Turkey, and Yugoslavia took place. And because it ends in results with the several volumes, which reflects the, let's say, the experience of the participating nations. The fifth of them, entitled Repair and Strengthening of Reinforced Concrete, Stone, and Brick Masonry Buildings, was aimed to, let's say, to give the instructions and to define the whole procedure of the repair and strengthening, drawn, of course, on the experience following all of these deadly earthquakes. And which is more important, it was agreed to be adopted by all these participating Balkan countries. Without going in details, what was written in this volume? So, as I said, this is the step-by-step procedure of post-earthquake repair and strengthening, starting with emergency damage evaluations, which should be done for each of the buildings by the inspection team and to determine the usability level. Then preliminary investigation, which should be done by the structural engineer to determine the cause, the nature, and to extent to damage, and of course, consequently, the need for emergency and temporary shoring. Definition of seismic parameters for the region. So it means this is the seismicity, the seismic potential of the region through different types of PGI, dynamic amplification factors or spectrums, etc. But all the countries agree that it should be defined. Then to design the criteria for repair and strengthening, many times mentioned here. The most global one, the most general one are these two ones that we have to have linear behavior of the structure during the moderate and slight earthquake, which can be, of course, correlated with the performance of the structure by the relative story displacement, but anyhow, ductility less than 1, because this is elastic. And we can allow to the building to have nonlinear deformation for the more severe earthquake, which means ductility more than 1 for different type of course, different numbers for different types, but not to disturb the global stability of the earthquake. So these are the most general that was adopted by the Yugoslav country then. Then we have to do an additional investigation, which is again mentioned several times here for the completion of the knowledge of as-built structure, which is documentation, as you say, investigation of the bearing elements, the built-in materials, construction details, and damage analysis and evaluation. Then it is following by the selection of the repair and strengthening method by consideration of variant solutions, of course, with enough detail, but for the selected one, complete analysis according to the design criteria. And final design procedures, also mentioned several times here, detailed calculation and structural analysis for defined seismic parameters for the code, for code requirements, etc. So all of this was written into the 1984 volume 5 of this very valuable conference. Of course, analysis should be done on the corresponding mathematical model with taking into consideration all the situation by the structure itself, the structural system, but the bearing materials, and it can result into the both repair or repair and strengthening. And of course, in this context, as it was mentioned by Professor Styliadis, a repair is only the re-establishment of initial strength of the damaged part, and the properly repaired structure should have enough strength, of course, but not enough, maybe somewhat reduced stiffness because of the fine cracks, which is impossible to recover. And it can be done, of course, after the damage of the structure. But strengthening is, or reinforcing, as it was translated by our translators here, is the judicious modification of the strength and or stiffness and or deformation capacity of the structural members or the structural system. And it can be done in different ways, either by the strengthening of existing elements or by introducing the new one for increasing the lateral, of course, resistance of the structure. Anyhow, the strengthening should bridge the gap between the existing and the required or demand strength and deformability. And in keeping with this philosophy and this panel, our institute, first of all, I would like to mention that on the territory of ex-Yugoslavia, these volumes are still regarded as the unmatched in defining of this step-by-step procedure and all of the explanation that is going with this. So in keeping with the philosophy of these manuals, our institute succeeded to repair and strengthen a number of structures, dozens of structures with different function, different structural systems and materials, of course, after the major earthquake in Yugoslavia. So this is post-earthquake, of course, strengthening. Now coming to the cultural heritage. So we know all of us here know that these monuments are vulnerable both to the man-made and natural disasters throughout the historic time and on nearly on each continent. we are witnessing the very heavily damaged of these earthquakes, of these structures during the earthquakes. Why it is like that? Because these are the brittle and very stiff structures with stiff structural elements, which prevent the structure to be able to, let's say, to sustain the deformation that is required by the earthquakes. But there is also intended damage to the cultural monuments, unfortunately. Like you can see here, for example, during the disintegration of Yugoslavia, the shilling of Dubrovnik, the blown up church in Mostar, the blown up masonry, old masonry bridge in Mostar, then the fire in the Prilep Mosque, detonation of the Lešak Monastery, fire in the Kosovo, and of course the final one, the civil war in Syria, etc. So there are many of them. So from the other hand, we can say that when we speak about the cultural heritage, we speak about the key element for the history and identity of each society, and of course contributing to its well-being. Due to their architectural, cultural, historic, even political and spiritual value, they deserve more attention, of course. And we might find some different consequences or different, let's say, the reasons if we have man-made or let's say natural catastrophe. But in any case, when we speak about the damage of cultural heritage, of course, the reason does not play anymore, because the problems are the same and the solutions should be the same. So we believe that the protection of monuments have been done only by the multidisciplinary approach, by the team of experts from different profiles, each of them very competent in its own profile, but at the same time very flexible to accept the argument from the others from the team. But still the main task or problem is how far we should go as to the level of safety and extent of intervention, because our moral and legal obligation is to protect the cultural heritage for the next generation in its authenticity. So the territory of North Macedonia, as you can see, is located in the center of the Balkan Peninsula, and that is why it is from the ancient times until nowadays, it is the crossroads of important traffic routes, which determine their rich but turbulent economic, cultural, and political history, full of spiritual influences, military campaigns, ethnic migrations, ups and downs, fires and earthquakes, etc. So each of these different culture and influence of sphere of influence left its own mark into the material and spiritual culture of the people. So most important archaeological sites are the, let's say, Tumba near Skopje, Eliknidos near Ohrid. This is some representative of the Neolithic settlements in our country. Then the ancient city of Stobi in the central part, and Stibera and Heraklea near Prilep and Bitola. And of course, the ruins of the Roman colonial cities, Skupi near Skopje and Bargala near Štip. Representative for the medieval times are the Byzantine churches in our country, which is of course the topmost architectonic creation, with the extraordinary collection of the valuable fresco paintings. We have more than 150, starting from 9th to 14th century. But it seems that the Ottoman presence on our territory for 500 years left its own mark and special traces into the physiognomy of the bigger cities, which is in the old part of the Skopje, old part of the Bitola, Prilep, etc., which are, of course, which is the cause because we have there many mosques, many inns, many hammams, clock towers, etc. But of course, because are located in one of the most seismic active region in the country or in the Europe, all of these monuments have been throughout the existing times have been exposed not only to climatic and man-made, but also to earthquake effects. So it was somehow confirmed with the Skopje 1963 earthquake. It was with the magnitude 6.1, and it was felt on the territory of about 200 kilometers, radius of 200 kilometers. And this earthquake inflicted inestimable damage to the monument fund. So entire monument fund was more or less damaged. It was manifested by the failure of individual parts, like in Çifte Hamam or Suli or Kurşumliğin here, large cracks, structural cracks, or inclination of some parts of the monuments, while some of them have been lost forever. So what happened in the post-earthquake treatment of the monuments? So what was the legal framework, I mean? So the recovery, post-earthquake recovery of Skopje starts in the periods where there is a lack of knowledge, lack of regulation, lack of everything which is connected with the earthquakes, because until then, on the territory of Yugoslavia, there is no such code or such provisions, etc. That is why the Yugoslav government starts the campaign for enforcing these guidelines and first code in 1963, as I told you previously. But in both of these documents, there are nothing special for the monuments. So this is only for the new buildings, etc. Maybe it's repair and strengthening, but ordinary structures. The first legal framework is in 1976. This is the Law for Protection of Cultural Heritage. But this is very first legal framework, but there is only let's say, some terminology, then the glossary, which are, connected with some labeling and categorization of the monuments, but very poor one, of course. And some very beginning of the process of the protection and organization of the protection. Then following after this were the Code for Design and Construction, improved Code for Design and Construction of Building in Seismic Regions, and Code for the Repair and Strengthening of the buildings. But again, there is the first one is for the new buildings, predominantly reinforced concrete and confined masonry. But the second one is for the repair and strengthening of ordinary buildings. So again, nothing special about the monuments. After the disintegration of Yugoslavia, in our country, we enforced new law for protection of cultural heritage, this time more precise and more detailed into the definition of the, or introducing the responsible institution, categorization of the monuments in parallel with the regime for protection and use, then guidelines for carrying out the conservation research that is mentioned several times here, and guidelines also for how can we elaborate the conservation projects. But besides all of this, there is also regulates some the rights and obligations of the owners, professional titles, other issues, etc. What is important to say that this law as a law is a legal framework. It does not speak about the content, about the material, about the method and techniques of retrofitting, especially seismic upgrading, etc. of the monuments. And that is why this very important, important role is conveyed by the team of architects, conservator, historian, structural engineer, and geologist. So this should be the team which will carry out the conservation research and conservation projects, of course. So the lead institution is, of course, Ministry of Culture, and in the parallel, the Directorate for Protection of Cultural Heritage. There are conservator centers which are responsible for the immovable heritage, museums responsible for the movable. And I would like also to emphasize here the activity of the National ICOMOS Committee, which activity is in the direction of increase the public awareness into the value and significance of the cultural monument in our country, and of course to enforcing the efforts for better treatment, promotion, revitalization, etc. So the new law for construction was in 2005, and in 2020 we introduced for the first time Euro codes, but in parallel with our national code, and we can say that our experience here is still exceptionally modest. So post-earthquake treatment monuments, but what was done on the field? So actually, so this starts immediately. This starts with the immediate structural consolidation, but in the process of renovation, especially of these which were for the modern needs monuments, the principle of repair and strengthening were involved. But unfortunately, on the level of that time knowledge, this involves reinforced concrete elements. Which are introduced in existing masonry. And there is a lot of them, I will not go into detail, which are recovered or reconstructed by the introducing of the reinforced concrete. Unfortunately, later on, during the visual inspection of the monuments, there was estimation that this cement, of course, can obviously affect the original bonding material, the lime mortar. And that is why during the ECC seminar in 1988, based on the idea of the architects and all the conservators and engineers which are participants on this conference, the final document, Skopje recommendation, recommends this multidisciplinary approach, which will connect all of these profiles and prohibits the cement in the next, let's say, retrofitting of the monuments. And since 1990 until 2000, we became partners with the National Conservation Center, provide many different projects which are connected with the finding of most appropriate ways how to seismically upgrade our monuments. And it, of course, includes large number of experimental verification of different retrofitting techniques. Most of them are traditional one by ties and injection, but also in our concepts, there are also base isolation and composite materials, as Professor Encielo says. And coming to the point, which maybe we disagree with you, that our starting point in our institute is that as a professionals working in this field, we should strongly oppose of existence of code for historic buildings and monuments. Why? Because the code been slow, and all of these monuments have been constructed in different times under the different flows. So we think that unification of the requirements in one code maybe lead to the negation of the monuments. But we, of course, recommend to acceptance to the guides, recommendations, resolutions, charters, and for the exceptionally valuable monuments to scientifically develop methodology, which will be, of course, implement later on. During the several decades of working on this theme, on this subject, our institute, let's say, adopted one integrated approach protocol, as I said, for this, for the development of this methodology, and this is very, very similar to what you are talking today. So, we are saying that it is the protocol, that it is the approach, not in the code. So, the first of all, we should review all the data, all the data we have. So, review the technical, the written, the photo documentation, archive investigation, because there are a lot of them in the past years. To conduct the interviews with the owners, to read all the professional statements, of course, as you know, as you said previously, to increase the knowledge level of the as-built structure. Then we have to define the real seismic potential of the site where the monument is by some seismic microzonation, and to develop this geotechnical survey and geotechnical models of this, including the soil profiles and soil effects, which will, of course, result in let's say the demand or required peak ground acceleration in our analysis. Then structural identification. Of course, we have to know, because these are once Professor Tassio says that the monuments are black boxes. So it means that we have to learn from the monuments. We have to spend time there just to see what are the structural, to identify the structural system, of course, and the bearing elements, etc. Through different in situ measurements, the investigation of the building materials. But what is rather specific is that in any case, we are providing the ambient vibration technique. This technique is, in fact, placement on the specific level, the very, very sensitive sensors, which can measure the vibration from the ambient. So from the wind, from the everything. Why it is very important? Because we are obtaining the fundamental periods and the mode shapes of the structure itself. And if this is very precise, we can, of course, let's say, to find out what are the disconnections, let's say, the points which are not good, etc., structure. So this means that it is something that it is very important because this is experimental testing in situ of the fundamental dynamic characteristics, which is identity card of any structure, of course. Then structural analysis, of course, there are different types, as you mentioned several times, but what we are doing, this is the 3D finite modeling, of course, but we calibrate, we modify the input values of this finite, for example, especially with the modulus of plasticity, until we reach that the fundamental period of the model structures is equal to the ones experimentally obtained during this ambient vibration testing. So this is somehow connected with the on-site situation with our mathematical model. Then we are providing two different methodologies, which I will speak in the next slides: bearing and deformation capacity and time history response. And of course, finally, we are coming to the seismic retrofitting. The most important thing in the seismic retrofitting is the definition of the safety criteria. So it means that, as a lot of us speak today, so we have to know what are the requirements that our structure should contain. Then to select the concept, to select the materials, methods, and techniques, of course, and provide verification structural analysis. Of course, definition of field works and subsequent documentation. All times having in mind that the strengthening or retrofitting should bridge the gap between the demand and existing. Now, the key elements are this definition of bearing and deformation capacity and dynamic response of structure for the defined seismic potential, which is except the point 2. What does we understand until this bearing and deformation capacity? So, of course, this is once again connected with the volume, this time volume 3. And this is under the bearing capacity of the story, one story of the structure, we understand the ultimate story transversal force, which compared with the demanded equivalent seismic force gives the safety factor against failure, while the deformation capacity is or the ductility, story ductility capacity means a ratio between the maximum story displacement and displacement at yield point. So what does it mean? That it is calculated by our in-house software according to the methodology present in this manual. You know what are the input values: gravity loads, masses, geometry, wall position, characteristics, and of course shear base coefficient or peak ground acceleration that is needed for the seismic parameters. Then we provide the limit state analysis of each of the vertical elements into the structure, or each of the vertical piers. So it depends on the level of the detailing of the modeling, by calculating the bending and the failure capacity, bending and shear capacity of each of the elements using these expressions here, representing the maximum horizontal force that the element is capable to sustain in the case of failure, either shear or bending. And of course, this after that results into the bearing deformation capacity, and this, as we call it, story Q-delta diagrams, which means that each of these elastoplastic lines represent the Q-delta diagram for each of the walls, and by summing of all of this, we are coming to the cumulated story Q-delta diagram, which is in fact the input diagram for the hysteretic diagram into the subsequent response to the defined seismic parameters dynamic time history analysis. The specificity here is that in this nonlinear time history analysis, we assume that our structure with the shear type structural model, which means that we assume that all the structural characteristics, masses, etc., are concentrated onto the story levels, of course. And in this analysis, the hysteretic models, as I said, is the cumulative story Q-delta diagrams, which is, of course, obtained by the summing of the Q-delta of the separate walls. And of course, with these input values, we are doing this nonlinear dynamic analysis, and the output was the time histories of the stories, displacement, velocity, and accelerations. And by comparing the capacity, ductility, displacement capacity with the demand, we can talk about the performance of our structure. For example, on this slide, on this photo here, so as you can see that what are the capacity during the yield And this is the ductility capacity at the ultimate point. So in this area here is linear performance, and this area here is nonlinear capacity for nonlinear performance of our structure. But our analysis will give also the demand or the required displacement for all of these stories, for example, at the particular peak ground acceleration, and we can compare which of the stories for which earthquakes, for which, let's say, peak ground acceleration have capacity or no. Similarly, we can compare the ductility capacity. This is ductility 1, which means this is 1, which means yield point, and this is the capacity of this particular building. I don't know which is concretely this. And all of this ductility demand, which is above this line, it means that they don't have the capacity. And very shortly, there are several slides which are implementation of this methodology, first of all, in historical buildings. These are the example of the Montenegro earthquake 1969, a heavily damaged one. What was provided 1980, 1981. So this was in situ testing for the comparing for the getting to determine the characteristic of the built-in materials, and then because the injection was the most convenient for this old town of Budva, 1 to 2 scale models was prepared in our laboratory. First of all, with the same stones coming from the Budva town in our laboratory. The first was in the original state with the original, of course, previous lot of investigation was done about the mortar, etc. And after that, after the damaging, the repair model was strengthened, and all of this, knowledge into the way of application, consumption, and effect was applied during 1 year and during the reconstruction of the Budva city. The second example is the historic adobe buildings in California. You know that after the Northridge 1994 Northridge earthquake, these adobe buildings suffers really severe damages and collapse, of course. And the Getty Conservation Institute started the Getty Seismic Adobe project in 1995 to find the most easier and most non-expensive methods for seismic upgrading of this structure. And as a, let's say, extension of this project, there is a shaking table testing at ISIS of 2 models in 1 to 2 geometrical scales, so very realistic one. One is the control model, and the other one is retrofitted with, as you can see, vertical and horizontal ordinary nylon strap with some plywood diaphragm inside. As you can see, it was really showed that this strengthening is very efficient because they don't have collapse on the same peak ground acceleration. And this ends with this planning and engineering guidelines which are issued by the Getty Conservation Institute with this, let's say, guidelines for this very not so very easily to apply, let's say, retrofitting techniques, and dozens of this structure have been retrofitted this way. I will not speak about the Parliament building in detail because this will be the presentation of my colleague Goran Jekic. I would like to just to say this was very challenging, many years lasting project during the designing process, but also during the construction. It was let's say successfully constructed and during the continuous function of the building, of course, and which is very important during the 2016 Skopje earthquake with 5.3. There is no structure, of course, but there is also non-structural at all. Implementation in the field of monuments. The first one is out of the 1975 Pagan earthquake, this Pagan plateau, which is with characteristic with magnificent pagodas and templates, that was very severely damaged during the Pagan earthquake. After that, this is once again, because you know this is this period where the UNESCO and UNDP efforts, this was principal investigator was our professor, emeritus Professor Gavrilovic. So they developed and implemented the methodology for repair and strengthening, once again, with the detailed geometrical investigation, ambient vibration technique, in situ inspection of the characteristic of the built-in materials, and it finally results into the inserting of the steel bracing horizontal across and or RC belts. And in the period after that, 15 pagodas and templates were, let's say, restored in this way. And what is one very important, during the 2016 earthquake with 6.8 in Myanmar, there is no structural damage. This example, of course, we are really, really proud, especially me, because this was the doctoral dissertation. So this is the project, the very unique one, scientific research project of conservation, repair, and seismic activity of Byzantine churches, which should first of all, which has two primary goals. So first of all, to see what are the vulnerability of the structure, and of course, what is the most appropriate ways of how we can seismically upgrade them. These are four structures for which ample laboratory in situ, I will not go in details, of course, investigation have been done. And these were selected as a more representative, of course, according to this criteria. But the Church of St. Nikita, which is very close to the Skopje, was selected as a representative for all of these Byzantine churches on the territory of North Macedonia for further in-depth analysis. And of course, for the shaking table test, which was done for the first time in the world in the one physical model of 1 to 2.75 scale model, of course, in its original state, then strengthened by Tyson injection as a traditional way. And of course, after that, like base isolated. And all of these projects have been done with the GCI financial support and further development program. What we'll see on this video, a very short video, is comparison of these two methodologies, traditional one and base isolation one. So this is for the earthquake, which is let's say the maximum expected for the 1,000 year. So this is, as you can see, this is the performance of the structure, which is with Tyson injection. Of course, heavily damaged, but still not disturbance the global stability. And of course, nothing special, I mean, during the base isolation, because all the energy is, of course, during the seismic isolators. Of course, this should be imperative maybe in future for these monuments, but we don't have the permission from the archaeologists. So that is why, although we prepared the project for the St. Nikita Church, there was not allowed. But we have a challenge to, let's say, to implement this in other several structures, but I have to emphasize that it is in the process of reconstruction of the church. So it means that we have some ruins, we have some part that we have, not the whole structure. And the first one is the St. Panteleimon Church in Ohrid, very important for us. It was a church, then mosque, etc. So these are the remains. And in the process of the project, there was strengthening of the foundation by the reinforced concrete elements and incorporation into the masonry, horizontal and vertical steel ties according to the previously experimental verified methodology, just to convert the church, the structural system from the plain one to the confined structure, or frame structure, frame masonry structure, if you want. And this is, of course, realized during the beginning of the 21st century. Nowadays, this is very important touristic place. Then the second one is the monastic church of St. Athanasius in one village near Tetovo in Skopje, near Tetovo in our country, which was exposed to the detonation during the armed conflicts in 2001 and experienced, as you can see, almost complete demolition. Only the belfries remained with some very heavily damaged part. In our concept, we have two approaches. The one, it is repair and strengthening with using of repair of reinforced concrete, because there is no frescoes, etc. in the part which was very heavily damaged, and complete reconstruction with maximum possible use of the same material into the of this demolished part of the structure. And of course, it is going down. You can see here these vertical steel elements. Once again, converting the plain masonry into the frame masonry. also it is completed. Then the implementation of the methodology, the reconstruction of the Church of Holy Trinity, which was blown up during the Yugoslavia disintegration in Mostar. Once again, there we started with the approach with the because our program, our task was to be masonry structure, not a reinforced concrete one. We starting with the three main general principles with the plain masonry, which is the dark blue, plain masonry with horizontal belt courses, which is the red one, but only the green one, which is the let's say the masonry with horizontal and vertical, according to the methodology, which was experimentally verified, reached the demand seismic force according to Euro Code 8, which was of course our task there. And it was also is lasting more than 10 years, of course, but nowadays we have completed also this one. The fourth one is now, you can just, I would like to emphasize, it is in seismic upgrading of all churches that are existed. So there is no now ruins, they are not part of the church, this is the churches. But of course, we are very restricted here not to incorporate vertical elements, but only horizontal one into the joint lines, facade joint lines, and connect it to, of course, to make the integration of this characteristic level, as you several times repeated, to tide up the church, etc., and to let's say to increase their seismic resistance. And the final one is the now mosque. So this is the once again scientific research project, which was one of the part that was realized into the framework European framework 6 Prohitec project. And it speaks about the seismic retrofitting of Mustafa Pasha Mosque, which is one of the biggest and well preserved in Balkans. And it is, of course, in Skopje. As if you remember, I showed this slide several, so it was heavily damaged, structural damage, inclination of the minaret. And after the Skopje earthquake, on the that level of the knowledge, on the depth level, the level of knowledge in that time, sorry, it was strengthened or upgraded with the reinforced concrete elements. Together with the Turkish Yildiz and Metu University from Turkey, we provide joint projects, several bilateral projects, and make the in situ investigation, taking samples, investigating the materials. Of course, once again, ambient vibration techniques with the fundamental periods and mode shapes. And we obtain also the qualitative testing of the wall elements just to have a good interpretation into the subsequent, once again, shaking table testing of 1 to 6 scale mosque model, realized in our laboratory in both original states. You can see very similar cracks during the Skopje earthquake, and strengthened by this time by the same philosophy, to tide on the several level, characteristic level, but this time with CFRP bars. The Professor Vincielus says very good that these are very powerful materials, and we need only small dimensions of the bars, etc. That is why they are very likely to operate. So we have a challenge after that to design this strengthening of the real Mustafa Pasha Mosque, and very shortly. So we have removing of the old cement mortar, injection lime mortar into the dome, then isolating this reinforced concrete belt course, and applying of course the CFRP wrap about 2.5 meters, and covering with the lead. Into the walls, we incorporated first of all, remove all the cements about 7-8 centimeters inside, and incorporated here the CFRP bars. It is about 7 millimeter bar, and of course with 2.5 or 3 centimeters mortar after that, just to cover from the, of course, temperature, etc. And beyond the terrain, we designed all around the church. Oh, sorry. Yeah, okay. Around the mosque and down to the foundation level, we designed the reinforced concrete wall, which is physically, let's say, separated from the old masonry with this polyurethane label, which was a requirement from the Turkish colleague. And following this very successful example, we also have very successful implementation of this CFRP into mosque in Pristina, in Bitola, in Ohrid, and nowadays there are ongoing project in Strumica and Prilep, all in our country. So I will finish with this slide that, for example, that the most delicate problem or challenge in these historic buildings are the selection of the materials, methods, etc., which can be successfully overcome by using of this methodology of design by testing, of course, which is also incorporated in the Eurocodes now. It is very powerful tool, especially for these complex structures, which are difficult and unsafe to analyze using traditional methods, of course. And about our institute's achievements to retrofit the monuments based on scientifically based and experimentally verified methodology, which was applied on the several very important monuments. And I would like, of course, to acknowledge all the institutional partners and the financial support for this project and all the colleagues for thoroughly implementation of this step-by-step design methodology for repair and strengthening. And with this, I would like to thank you once again for your kind attention and invitation.